Hello, my name is Cassidy Pickett, and the chapter I decided to lecture on today is Chapter 5.1, Probability Distributions. So the first thing we need to know going into this chapter is some definitions. What is a probability distribution? Usually it's a table, a formula, or graph that represents a set of probabilities for each value of a random variable. That random variable is usually denoted by x, and it has a set of given numerical values for a procedure which is determined by chance. There are two types of random variables. The first type is discrete random variables. This is values that are countable. They're not an infinite number. So an example of this would be like the number of times a place was called, or number of people in line at a store, or number of times heads was flipped out of 10 coin tosses. A continuous random variable are values that are not countable, or that are moving or staying at a constant rate. So a couple examples of a continuous variable would be like body temperature, which usually stays around a certain number, time, and volume. Other things like length are included in this too. So there's three requirements for determining a probability distribution. The first one is that numerical values of the random variable x are aligned with their corresponding probabilities. The second requirement is that the sum of all the probabilities are equal to 1. And the third requirement of a probability distribution is that the value of each probability is between 0 and 1. And so here we have each of those formulas. This is for the sum of all probabilities equaling 1, and the value of each probability being between 0 and 1. So here's the first example. Is this a probability distribution? So the first thing we're going to look at is the first requirement, which is that all of the values are countable and are aligned with their corresponding probabilities. Since we see that these are not infinite numbers and they're simple and able to be counted, and they're also aligned with probabilities, this requirement is met. The second requirement says that all the probabilities have to add up to 1. So here we can see that 0.18 plus 0.34 plus 0.35 plus 0.11 plus 0.02 equals 1. So the second requirement of a probability distribution is met. And then the third requirement says that all probabilities are between 0 and 1. So just by looking at this column here, we can see that all of them are decimals and in between 0 and 1. So this is a probability distribution because all three requirements have been met. Here we're going to look at how to actually calculate the mean, variance, and standard deviations of a probability distribution. And when we're looking at this, x is going to represent the random variable, and p of x is going to be the probability of that specific random variable. So here we have the mean equals the sum of the random variable times its probability. The variance is the sum of the random variable minus the mean squared times its probability. And then the standard deviation is just going to be the square root of the variance. So in order to find the total mean and variance, you're just going to add up each formula for each random variable from each row, and add those up to be the total mean, and then same thing for the variance, and then take the square root of the total variance to find the total standard deviation. So the way to know where to place your decimal when you are working with probability distributions is using the round-off rules. So you're going to want to pay attention to the decimal place that the random variable is in, and you're going to carry over one more decimal place. So if the variable x is rounded to 2 decimal places, then you're going to carry yours over to the 3rd decimal place. However, if the x's are integers, you're going to round all those parameters to only 1 decimal place. The exception to this rule would be if you're trying to find a probability out of 5 of something, and your probability is 4.999678. Since rounding to 5 would suggest 100% or 5 out of 5, perfect score, and it's almost there, but it's not 5, you're going to leave it as is, and keep it at 4.999678. The next value we're going to talk about is the expected value, which is represented by variable e. It's the average score of the probability, so it can be found using the same formula as the mean, which is right here once again. So here for example 2, we're going to go ahead and find the mean, variance, and standard deviation of this table. So here for example 2, we're going to be finding the mean, variance, and standard deviation for this chart. For the mean, we have this formula right here, which is the random variable times the probability of the random variable. So for the first row, we have 0 times 3.4 is 0, 1 times 0.52, 0.52, and 2 times 0.14, which gives us 0.28, and adding those together, a total of 0.80. For the variance, we're going to go ahead and use this formula right up here, which is the random variable minus the mean squared times the probability. So for the first row, we have 0 minus 0.8 squared times 0.34, which is 0.2176. 1 minus 0.8 squared times 0.52 is 0.0208. And 2 minus 0.8 squared times 0.14 is 0.2016. So when we add these up together, we're going to get a total variance of 0.44. And then to find the standard deviation, we're just going to take the square root, which is 0.663. Then we see here how each of these variables is an integer, and then we're going to go ahead and round each one to 1 decimal place. Here are our answers: 0.8, 0.4, 0.7, and 0.8. Once again, since all of these are integers, we're going to only round to 1 decimal place. For example 3, we're going to be finding the expected value of gain for playing at a raffle. So there's 1,000 tickets sold for $2 each, and prizes of $500, $300, $200, and $100. So the first thing we're going to have to do is put in those prize values into the top, or the possibility of gaining. But we want to factor in the $2 we spent on that ticket. So we're going to have each of these values just minus 2 to show what the true value of gain would be. And then on the bottom, we're going to put the probability of winning that prize if you only buy 1 ticket. So here we have the chart all filled out: 498, 298, 198, 98, and -2, just to factor in the chance that you don't win any of the 4 prizes. And the probability of winning each one is 1 out of 1,000. And then to find the probability of your loss, you're just going to add up all these probabilities and subtract them from the whole, which is 1,000 out of 1,000, or 1. So 1,000 out of 1,000 minus 4 out of 1,000 is 996 out of 1,000. And that's your odds of losing $2. Then to calculate the expected value, just as we calculate the mean, we're going to multiply the random variable x by its probability, and then add them all together to find the total mean. So here we see each of those added together to equal -0.9, which means you can expect to lose money with every ticket that you purchase. To find the significant values, we're going to use the range rule of thumb, which is based on the principle that all values should fall roughly within 2 standard deviations of the mean. So in order to calculate these, we're going to find the significantly high values by seeing if there are values greater than or equal to the mean plus 2 times the standard deviation, or 2 standard deviations. Significantly low values are going to be found using the same formula, but just subtracting the 2 standard deviations from the mean instead of adding them. And then all the non-significant values are going to be the values that fall between those 2 numbers. The final rule for this chapter is the rare event rule, which just states that if the probability for a given random variable is less than what we consider to be significant, which is less than or equal to 0.05, then we can assume that the claim is probably incorrect. So for example, if you're testing the assumption that a coin will show heads 50 times out of 100 flips, and you get 15 heads in 100 coin flips, you know that you can reject the assumption and that it's probably not true. So here we have the last example for this chapter, and we're going to just find the mean, variance, and standard deviation, and then use that to find the values that are significantly high and significantly low. So for example 3, we're going to be finding the mean, variance, and standard deviation for this table, and then using that to find the significant values. So for the mean, we're going to go ahead and do the random variable times the probability, which gives us 0 times 0.24 is 0, 1 times 0.57 is 0.57, 2 times 0.16 is 0.32, and 3 times 0.03 is 0.09. We're going to add these all up together to get a total mean of 0.98. Variance, we're going to do our variance formula, which is the random variable minus the mean squared times the probability. Do this for the first row across, we're going to get 0.23. For the second row, we're going to get 0.00023. For the third row, we're going to get 0.17, and for the fourth row, we're going to get 0.12. We're going to add these up together for a total of 0.52, and we're going to find the square root of that for the standard deviation, which is going to give us a 0.72 standard deviation. Once again, our random variables are integers, so we're going to round all of these to 1 decimal place. And then to find the significant values, we're going to just do the ones that are within 2 standard deviations of the mean. So to find the significantly low values, we're going to take the mean, which is 0.9, and subtract 2 times the standard deviation, which is 0.7. So that's going to give us 0.9 minus 1.4, which gives us a significantly low value of negative 0.5. And for significantly high values, we're going to do the same thing, but just adding together. So it's going to be 0.9 plus 2 times the standard deviation, which is 0.14, to give us 0.9 plus 1.4 equals 2.3. And here are those values. We got 0.9, 0.5, 0.7. For all of the random variables, since they're integers, we're going to only round to 1 decimal place. And then for our significant values, we have our significant values are those equal to or less than negative 0.5, or those greater than or equal to 2.3. That is chapter 5.1. Thank you so much for watching.